In the name of Allah, the most gracious, the most merciful, praise be to Allah, and peace and blessings be upon the messenger of Allah, our master Muhammad, and upon his family and all his companions. Now, after finishing the general discussion in the first episode and talking about it in the second episode, we begin a new episode with a new challenge and practical information that will benefit you in the job market about current transformers. As for the CT tests, they are the same as the VT test, and the VT tests are the insulation test, the winding resistance test, the ratio test, the polarity test, the primary and secondary injection test, and let's not forget the loop resistance test in addition to the burden test, but we replace the word VT with CT and add the CT magnetization curve to it, and we will explain all the tests again, but with new, beautiful, and non-boring information, God willing. The first test is the insulation resistance test. Insulation is crucial for equipment. If the insulation weakens or fails, this equipment is useless. The phases must be insulated from each other and the ground to avoid faults, as short circuits occur from phase connections or to ground. Due to insulation's importance, we list resistance tests. First is the hypo test. Perform IR test before and after the hypot. Note, hypot is for power circuit, primary side only, discharge after each test. We start with the IR test. If it fails, CT tests are unnecessary as CT would be rejected. Insulation is crucial, so we conduct insulation resistance tests, starting with the hypo test. Before and after the hypot test, perform the IR test. The hypot test is for the power circuit. Discharge charges after each test. The insulation value rule is 2 megaohms per kilovolt. When conducting the hypot test, you should perform the IR test before and after the test. It's important to note that the hypot test is only for the power circuit, meaning everything on the primary side, and you must discharge any charges after conducting each test. We must remember that insulation values should match the rule. Every kilovolt equals 2 megaohms. For instance, at 11 kilovolts, the minimum insulation resistance is 22 megaohms. Tested for 1 minute, faults decrease. Resistance over time affecting insulation quality. The CT-IR test involves applying DC voltage, 5 kilovolts from primary to ground, 1 kilovolt from primary to secondary, and 1 kilovolt from secondary to ground or secondary to secondary, all for 1 minute. The hypot test or high voltage test uses the same method as the VT episode. It can use AC or DC voltage applied for 1 minute on new equipment as per the table. For example, for the hypot test, apply 5 kV on primary to secondary, 1 kV on secondary, and 1 kilovolt on the secondary to ground, all done for 1 minute. The hypot test follows the same method we mentioned in the VT episode. It can be conducted by applying either AC or DC voltage, applied for 1 minute for new equipment. For instance, to test a bus bar rated at 30.8 kV, apply 28.6 kV for 1 minute, calculated as 30.8 multiplied by 2 plus 1 kV. For DC, apply 48.6 kV, calculated as the AC voltage multiplied by 1.7. For used equipment, apply 20.7 kV AC to each phase for 1 minute using the following formula. To test the hypo for a 30.8 kV bus bar, apply 28.6 kV. It's 30.8 times 2 plus 1 kV. For DC, apply 48.6 kV, multiplying the AC voltage by 1.7. For older equipment, apply 20.7 kV AC per phase, 1.5 times 13.8 kV. For DC, apply 31.59 kV, 65% of the new equipment voltage. This value comes from the equation stating AC voltage is multiplied by 1.7. For older equipment, use this table. For an old bus bar rated at 30.8 kV, apply 20.7 kV AC to each phase for 1 minute, as per the equation, 1.5 times 13.8 kV. For DC, apply 31.59 kV, since used equipment voltage is 65% of new equipment voltage. However, using DC and hypot test is not recommended because it creates a constant magnetic field, leading to treeing or water treeing, which may cause insulation breakdown. It is 1.5 times 13.8 kV. However, if we want to apply a DC voltage, we apply a voltage of 31.59 kV. According to the equation, the applied voltage in the case of used equipment is equal to 65% of the applied voltage in the case of unused equipment. DC supply in hypot test is not recommended as it can cause treeing. Some defects are missed with DC. AC versus DC. AC is large, high energy. DC is small, less energy. AC doesn't affect lifespan, simulates actual voltages. DC can cause treeing. AC reveals most defects. DC detects thermal defects. It also shows some defects undetected with DC. The table compares AC and DC in hypot tests. As shown, AC equipment is large, DC is small. AC uses high energy, DC uses less. AC does not affect lifespan as it simulates network voltages. DC impacts lifespan due to space charging, leading to treeing. AC reveals most defects. DC only thermal. It doesn't affect the lifespan of the equipment or the cable in general because it's simulating the actual network voltages. On the other hand, DC supply voltage has a significant impact because it can cause space charging, which can be the beginning of treeing or water treeing. Using AC supply voltage in the HIPAT test reveals most defects, while DC supply voltage only detects thermal effect defects.
The second test for insulation is the tan delta test, also known as the Los Angeles test or the dissipation factor test. This test is used to measure the quality of insulation and predict its lifespan. Usually this test is not part of the site tests, but is included in the power transformer tests. Changes in the home or water intrusion increase losses, which then convert more air into a phase in the house. The percentage of this change is indicated by the ball change ratio or the power ratio. The change ratio of 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 the change ratio. Rise in capacitance over 10% can be risky. The partial discharge (PD) test detects small electrical sparks in insulation caused by air voids or defects. It predicts insulation failure. Used in power transformers or cables, PD maps dielectric balance in insulation. Partial discharge, or PD, refers to the occurrence of small electrical sparks within the insulation. Each spark results from an air void or a defect in the insulation. Since partial discharge usually happens when the insulation is on the verge of failure, this test allows us to predict the future of the insulation. This test is not part of the site tests. Rather, the PD test is used in power transformers or cables. Partial discharge, PD, is the balanced dielectric mapping of electronic insulation piece by piece. They can be introduced from lines or lines in a proper dielectric, and in accordance with a proper dielectric or a noticeable dielectric. A group within a solid dielectric at interfaces within solid or liquid dielectrics, at interfaces within solid or liquid dielectrics. In a group within liquid dielectrics or during maintenance between different insulating materials. The PD discharge causes continuous insulation breakdown and can lead to electronic insulation failure. The PD discharge can lead to the elimination of hazardous situations and significant risks, ultimately resulting in substantial economic dangers. National Renaissance.